Well, the first thing I noticed is the AC started blowing warm. Then I noticed the temperature's rising. When I come to a stop, it even goes up higher. When I'm rolling, it's just fine. We're gonna have to find out why our charger's temperature is rising. Today on Tech Garage, we'll fix this sick charger. Welcome to Tech Garage, presented by Advance Auto Parts. Well, we got our charger in the shop, running a little hot, but made it nevertheless. Brian, our charger's illin', man. The temperature's rising.
Well, there can be a lot of symptoms. What do you got going on? What's the symptom?
Well, number one, the AC started blowing warm. You know, that makes sense because the condenser's located right inside there, right in front of it. So if it's getting hot, that means it's going to transfer in the AC. I'm not too concerned about that. I'm really worried about the cooling system.
What else is going on?
Well, here's the deal. I stop. And when I go, mostly stopping and go traffic, it really starts to rise. Then what happens when I'm rolling along, it starts to cool down, man. That's an airflow or a coolant leak issue, basically.
I'll tell you what, that can be a lot of things. So we need a proper diagnostic here, and we probably need a pressure test. You know, it's warm, it's not hot. I did some just basic investigating here at hose clamps and whatnot. I didn't see anything. So I'd like to do a full-blown pressure test.
That's probably the best thing to do. Here's a tip for you. When you pop your hood, you know, you can look at that reservoir. If it's full, I'm thinking maybe electrical. If it's empty, I'm chasing the actual coolant leaks, but don't forget, someone might have just filled it up. So you need to perform those tests, and you need to perform them proper. I'll get a demo set up to show how a coolant system works. You get to work.
Perfect, I certainly will. Now, again, a lot of things this could be. And when you're dealing with antifreeze, sometimes you can almost taste it, you can certainly smell it. And in this case, I'm looking for any kind of steam, any kind of vapors leaking, and I haven't seen anything. So, Mighty Vac makes this awesome tool, a tremendous tool to have in your shop. That's a pressure tester. Now keep in mind, the vehicle's warm, not hot, so it's safe to work on, but I am going to be safe here. I'm using safety goggles, and I want to come over here in this pressurized system and back the cap off and just let it burp a little bit. It didn't even do that, so it's not terribly hot, but it's warm enough certainly that we can service it. I'm going to get this off. I get the Mighty Vac cap on, a little bit of oomph right there, and this pressure tester hooks right up only one way. And what we're going to do, we're going to put the same amount of pressure in the system as this radiator cap calls for. In this case, it's 18 psi. So I'm going to go ahead and pump this up, and then we're going to leave it sit for 15, 20 minutes and see if it bleeds off at all. 15, 16, 17, and 18. So if the system's not leaking, this won't bleed off. If it does, we'll start chasing down the leak somewhere in the line. But in the meantime, John's going to walk you through an entire cooling system and show you exactly what's going on.
Now, the coolant system's job is to remove the heat from the engine and get rid of it. It does it by the law of thermodynamics. Well, sounds pretty complicated. Heat moves from a place that contains heat to less heat. Let me show you how it works. All starts down here at the bottom of the radiator, and the first place it goes is to the water pump. Now, the water pump's the heart of the coolant system because its job is to circulate the actual coolant around the block. You can see it here. The impellers pump it, and it spins into the block, and then it comes up the head. Well, why do we want to go around the block? Well, I got my little glass bottle here. Once again, you can see this. This is the cylinder. Inside of that, you have your piston. Every time the piston comes up and down, it's going to fire. It's going to create an immense amount of heat in that cylinder. Heat goes from hot to less heat. It's going to come out here to the coolant. It's going to transfer to it, and then it's going to take a ride back to the radiator. But before it does that, it has to come up here through the heads, and then a thermostat's located right here in the intake manifold. The thermostat's job is to actually keep the coolant in there so it'll stay hot, and it regulates the temperature. They're rated at different ratings, so it's going to go up and down depending on rating and temperature. Then what happens? It simply grabs all the heat, comes up, returns to the radiator. Now the radiator is located in front of the car. You can see a cutaway one right here. Now the radiator has these fins in it. What happens is the coolant circulates through it, and as it circulates through it, on the back of the radiator is a fan. The fan spins, and that speeds up convection, and it allows the heat to transfer from the engine, which was really, really hot, to the front, to the outside air ambient temperature, 70, 80, 90 degrees. We're getting rid of it. But don't forget, one other piece of the puzzle. Located inside the car, you could have a heater core. When you pressure test it, look inside the car as well and see if you have any leaks inside. Now I can show you this one in action. It's pretty cool. We got the thermostat out of it, but you can see it actually flowing the coolant through there, and it's running through. So we're taking the heat from the engine to the front, bam, getting rid of it. Now what Brian did, he actually pressurized the system. And when he pressurized the system, everything has pressure on it at that point. You can go out there and get some of this dye. It's multi-purpose dye. You can put it in the system and you can check for leaks. This is pretty cool because this will seep out or weep out. And you can see I actually put some right here on my heater core. And you can see up in the corner, the actual dye's starting to seep out right there. Time to replace the heater core. So that's a good look at that. Now, Brian's got it pressurized, so what Brian's gonna find is either it's gonna bleed down. That means he has a leak. That could be two possible places. Could be an external leak because one of the components are leaking. In that case, we're just gonna replace it. Can be internal as well. Our cylinder jackets may leak by, bleed into the oil. You wanna check your oil for a little bit of milky condition. If you got coolant in there, could be a head gasket issue or something along those lines. Now, if it's not bleeding down, he's got an electrical issue. We'll find out what he found out when we return with more Tech Garage right after this break.
Welcome back to Tech Garage, presented by Advanced Auto Parts. Well, we got good news and we got diagnostic news. The good news is the system held the pressure. It's been more than 15 minutes and we're still at 18 psi, so I feel really good about the sealed nature of the system right now. While I waited, I actually climbed inside, pulled back the rugs. I was looking for any kind of seeping or weeping of antifreeze from the heater core. It also looks great. So we've got to move on to the electrical system as it relates to the cooling system. What that really means is check the fans. So step one was to go to MotoLogic and find the fan relay, which we've located right here. Now this is a complex circuit, so we're going to take our time. I'm going to pull that relay out, and what we're going to do is test for voltage down to the fans and see if those motors will run. See these little T-pins right here? You can get them at Walmart in the sewing section, but this is what you need so you can get your alligator clips on for your DVOM and your jumper. So we got to go to the high amp side of the relay. Now here's a little tip. Many times these relays have the information on the side of them, but it is brutally hard to read. So you may have to look up this information online and see exactly which pinholes you need to hit. So we're going to jumper the high side down to the fan circuit. Put the T-pins in. Now, this too, invaluable tool, one of the cheapest ones to make, but you gotta have it. It's a fused jumper wire, so we're not gonna do any damage to the computer or anything else because we'll blow the fuse first if I touch something the wrong way. So the next step is let's connect the high side to the fan circuit. This is the high amp current. Through a jumper wire, we're good. Now, the fan should be running at this point. The next step is, since they're not, we're gonna disconnect this wiring harness connector, pull it aside, and one step of validation here. I know from my MotoLogic diagram which side's the negative. Now what I'm testing here is the leg down to that fan connection, that harness. And if the fan motors are bad, we should see 12 volts right here on our DVOM. Let me get it connected, and there you go, 12.5 volts. The problem is the fan motors. So I'm gonna get this swapped out. You know what, it makes perfect sense. John said that in traffic, this thing would heat up, and on the highway, it was manageable amount of overheating. So I'm gonna go ahead and get these fans swapped out. John's gonna show you how it all works.
Well, Brian jumped the relay and he didn't get his fans to run. What is a relay and how do the coolant fans actually work? Well, no worries. A-Tech sent us this complete cooling fan on a board with relays intact. Now, most cars today work the coolant fans through the actual computer, the PCM or the electronic control module located right there. So they're computerized. Well, what does that mean? That means there's different criteria that turns them on. Right here we have an air condition pressure. A lot of times when you turn on your air conditioning, your coolant fan should come on. on. Why? I got to get the air across that condenser. Now over here you got temperature. That also controls the coolant fans. Some come on at 232, some come on at 252. Just depends on your make and model. Maybe one at 232, the other at 252. So you have to check for your service manual to see when they come on, but they do come on with temperature. Now jumping his relay, that's hugely important. Why do we have a relay and what is a relay? Well, it's a mechanical switch is what it is. It switches a low amp circuit and allows high amps to go through it. So that's super important. You can see down here, this is the low amp circuit right here, the little ones. That's what the computer is going to control to magnetically pull in the relay and make it work. So Brian was very, very careful to get on the high amp side. He took a fuse jumper wire, which was hugely important because we don't want anything to go wrong. We want to blow the fuse in case we get it wrong and not mess with the computer up there and make sure it works. Then he took the high amp side here on the big leg and he jumped completely over the relay. And if it was working, the fans should work. They should both blow. So what happened is I bypassed the relay and I know the circuit's good up to there. Now, when you're checking this, the fans may run. Don't condemn the relay. Remember, there's criteria that the computer has to use to pull that relay in to make it work. So you're gonna have to make sure that he's asking for the fans to actually come on. Now, Brian, he's about got it whooped. He's ready to test it. I hope he fixed our charger.
There we go. Final mounting bolt on the new fan. Here's the old one. It's out. It's not that big of a job, really. 2 tabs at the bottom, 2 10mm bolts at the top. Now, the moment of truth. Let's test this circuit, reconnect it, and validate the repair. There's the click. Left my T-pins in. Remember the jumper wire, still fused. When I connect these, we ought to have our cooling fans run. There you go. Now that's cool. That validates the repair. I think John can drive wherever he wants, however he wants now. Be sure you get your relay back in the right way, get everything buttoned back up. The one thing we didn't talk a lot about was a thermostat, but you're going to see how important that is to the system on the Project Resurrection RSX after the break. Stay with us on Tech Garage, presented by Advance Auto Parts. All right, well, welcome back to Tech Garage. The RSX Resurrection project is well underway. The next stop, the cooling system. Now, you might remember when we were working on that air conditioning condenser up front, just how nasty the radiator was. We had contamination, dirt, damaged fins. It wasn't pretty. Well, I wish we'd have done this before paint, but we couldn't live with ourselves without a massive upgrade to the cooling system. Not too terribly hard to do. We had about 8 mounting bolts, all 10mm, all across the top here. I've got most of them out. I'm going to work this up out. It's going to be tight. There's probably no more than a 64th of an inch clearance, but this is going to be an awesome system. And of course, anytime you're working on a performance cooling system like this, you got to replace that thermostat. But first, look what Misimoto sent us. This is an awesome radiator. Better cooling surface, more of it, a lot of real estate. It's way lighter, which is less weight hanging out over the nose in those corners we're talking about. Can't wait to see how this performs. And then look at the cooling fans. Super, super light, but a tremendous amount of real estate and cooling surfaces. So this is going to be awesome. And you remember, anytime you're putting a radiator in, be sure you use cardboard here. You got to protect those fins. That's where the cooling and the magic happens. So I'm going to finish up getting the old one out. I'm going to jump into the thermostat next. And if you want to understand how a thermostat works, I think John's cooking something up.
Well, I'm cooking something, Brian, and it's definitely not your lunch, but we'll get to that in a minute. Why do we want to replace a thermostat? Well, every time you get a car hot or overheat, it's a good practice to go ahead and replace it. Now, Brian's going to replace ours because we're going through the complete cooling system. But if you get a car hot, you have to replace the thermostat. Why? Well, you can see one right here. It's got a little wax pellet in it. It gets hot, it gets cold, it goes through heat cycles, and eventually they start to stick. That's a problem. You can overheat a car, you cook it, that's catastrophic engine failure. So it's a simple little fix if you get it hot. Also, go through your hoses. I mean, you can see inside this hose here, it got a little bit hot, starts to get all crusty in there. It starts to actually scale, starts to get non-pliable and thick. It starts to crack. You're going to have a problem. So go through your hoses and go through your thermostat. Now, Brian's thermostat actually is located right here. We have another one right here that he's putting on. It's part of the whole housing assembly. You can also have a thermostat sitting just like this. I'll show you on our engine. Our engine over here has a thermostat in the housing. You can see it right up here. So if we pulled that out, remember earlier I told you we had ours out because we're actually just flowing the coolant through, but if it had one, it would be right there. You remove it, take it out, change it, put it in, clean the gasket, put it back. It's really a simple process, and it's a heck of an insurance policy when we're talking about catastrophic engine failure. What does an engine thermostat do? Well, it keeps the coolant inside the engine until it gets to a specific temperature. Why do we want to do that? Well, it's all about emissions. You get that engine hot in there, you burn the emissions, you reduce tailpipe emissions, so the manufacturers will allow the coolant to stay in there till it gets a specific amount of temperature. Well, what's the temperature? It's all about the rating. You can see our superstat right here. Now, this is really cool. Shows you on there it's 195 degrees. Well, what does that mean? It's going to open at 195 degrees and close at those temperatures below there. It'll actually open and close. The superstat's really cool because it has a bypass. So it fails, it's going to allow the coolant to still go through and you're not going to have catastrophic engine damage. Now, what am I cooking? It's the highlight of my day. I'm cooking a thermostat. So we can show you exactly what's going on. This water's boiling at 212 degrees. Then what happens, this guy should be open because I got the superstat in there and it's boiling at 212 and it opens at 195. So when I pull it out here, I'll show it to you with my careful prongs. And you can see it right there, that big gap, that means it's wide open. Now what I'm gonna do, I'm gonna dunk it in this water, which is cold, and if it's working properly, it should just start to close. I'll cool it and I'll bring it out real quick because it's gonna close pretty quickly. There it goes. And it's actually closing up. And then on this side, it's gonna keep the engine coolant in there till it gets hot. Once it gets up to the 195 degree rating, it's gonna allow it to flow, transfer that heat, thermodynamics in the radiator. Well, I can't wait to give our RSX a test drive when Brian gets the coolant system done, but for now, I'm gonna head over to Burnyzz and check out some high performance coolant systems. We'll be back with more Tech Garage right after the break. Welcome back to Tech Garage presented by Advanced Auto Parts. Well, today's performance playbook is all about the cooling system, or in this case, lack of one. Josh, you don't even have a coolant system on this car. How do you maintain engine temperatures?
We don't. Essentially, as soon as we start the engine, we've initiated a meltdown process.
Well, how do you keep it from melting down? How do you minimize the temperatures?
A little shorter burnout, get back into the staging lanes quickly, and hope that the guy in the other lane is being honest.
Being honest, what does that mean? Is there a difference?
Yeah, our car runs nitromethane, and some of the cars in our class are top alcohol, so that means alcohol, and they have significantly less charge temperatures.
So they're not going to melt down near as quickly as you are. Once you hit it, you're going quick. Let's talk about a little bit of the aerodynamics.
This car has a front and a rear wing that provide between 3,000 and 4,000 pounds of downforce.
Downforce, so we can just pitch them the other way and take off like an airplane.
Yes, sir.
Well, coolant systems play an important role, not just to keep the engine cool, but there's a huge effect when it comes to performance cars and tuning. Let's check in with John.
This is a 2015 Mustang supercharged, running a TVS supercharger. The cooling system is an upgraded cooling system. It's running an aluminum catch can that will help dissipate the heat a little bit more and faster than the regular plastic catch can. At Advanced Auto Parts, we also use some of their water wetter stuff to help with the temperatures and help kind of cool it down to keep the downstream temperatures cooler. It's important to keep the temperatures down is because the vehicle will actually start to pull timing out as it gets hot. More horsepower, less timing. Supercharger runs its own separate cooling system in a separate tank to help kind of keep those downstream temperatures down as much as possible. It runs a full circulation with the key on. The cooler you can keep your air intake temperature sensor, the more power you can make long term. You can use other things like methanol injection to help cool the air. The cold air intake, where it ports the air from the front bumper, will actually help keep the downstream temperatures down lower. It'll keep the charge temp lower also. Cooler, denser air makes more power. So when you change the thermostat to help keep the temperatures down, the engine is wanting to be cooler, it's circulating the water more. When we program the vehicles, it sometimes will require a cooler thermostat sensor in it in order to make it run a little bit cooler to keep the water circulating through the system.
That's the lowdown from Burnyzz. Now it's time for the email question of the week.
John Sam from Huntsville emailed this week. He's got a 2010 Ford Fusion that's getting worse and worse fuel economy. This week it tripped a P0128 code, and he wants to know if that could be related.
Absolutely is, Sam. That's an engine coolant temperature code. Now here's what's going on. The computer can be lying with an engine coolant temperature sensor or a thermostat. We looked at that a little earlier. If the temperature sensor is lying, what's going on is it's thinking the air is a lot colder than it is. That thing's going to be dumping a ton of fuel in there. You're going to get bad gas mileage.
Right, these things can get sludged up. You got to check that.
Yeah, you do, and I can show you it's real easy. There's a temperature chart you can find. It actually shows you exactly what the resistance is, and this one's sitting right there. Now, these are negative or positive coefficient thermistors, and this is a cool demo, because here's how it actually works. I'm going to fire up this torch. You see when I hit that, resistance is dropping and falling down to nothing. Well, that's what's going on. The computer actually takes this resistance value, he calculates it, and he can determine what the temperature is. If he's lying, bad fuel mileage.
Well, on our Charger, you saw we did a full diagnostic on the cooling system. Remember, it was overheating in stop-and-go traffic, a little bit hot on the highway, so we had to do a full diagnostic. Now, a tool we didn't show you that's really handy when you're trying to discover what's wrong is a pyrometer. If you get the engine heated up, you take your pyrometer, scan your radiator, you're looking for cold spots, and that'll tell you exactly if you've got a radiator problem, you can start and finish right there, or if you have to chase down more symptoms.
You know, and I like that. You can shoot the different sides of the heads, you can shoot coolant hoses, you can check for restrictions. That's an awesome tool. We're about out of time for today, so follow us on Facebook, Twitter, and YouTube. And like always, thanks for watching Tech Garage, where we get you back on the road.
Production assistance for Tech Garage is provided by Chipola College, located in Marianna, Florida. Founded in 1947, Chipola College is a member institution of the Florida College System, with a current enrollment of over 2,000 students. Chipola offers bachelor's and associate degree programs, as well as college credit and workforce development certificates. Chipola was recently ranked as one of the top 3 community colleges in the United States.